Okay, let's put that last video into action. Refresh your memory here. These are the formulas for the trapezoid left and right hand approximation with rectangles. And we are going to do an example now. We're not going to draw so much. The last one was a lot of drawing of pictures. This one, we are just going to use the integral. Find the value obtained by using 5 circumscribed rectangles of equal widths to estimate the integral of x squared from 0 to 1. Okay, so first of all, 5 rectangles from 0 to 1, that means delta x is going to be 1/5. You have to just do 1 minus 0, b minus a over n. So from 0 to 1, each rectangle will be 1/5 distance apart, or 0.2 if you want to use a decimal. All right, here's the deal. Circumscribed, we have to figure out which one that means. This is considered inscribed. When it's inside, the underestimate is inscribed. The overestimate is circumscribed. So in this case, inscribed, notice it's an increasing function, so the left side will be the underestimate. So that means that the overestimate will be the circumscribed, which is the right side in this case. So you have to figure out which one's which. Circumscribed is the overestimate, it's the one that goes outside of the graph. And, if you don't have those memorized, it's not a big deal. Just draw a quick sketch, x squared from 0 to 1. We know that's a parabola. Okay, so now that we realize that we're going to be using the right-hand rectangles, let's go back to that formula again. Looks like this. It's crazy looking. But we know that our delta x was 1/5. And it's really just the area of rectangles. It's 1/5 times the height of the first one, 1/5 times the height of the second one, third one, fourth one, and fifth one in this case. So remember, when you do the right rectangles, we're going to use the y value of b, but not the y value of a. So when we plug this into the formula, we have the y values come from x squared. So let me back up for a minute, go back to this picture. This is the y value of b, the y value of all the points less than that, but not a. We're not going to use this y coordinate. So when I want to know the y coordinates, the height of each rectangle, it's going to be like x equals 1, x equals 0.8, x equals 0.6, x equals 0.4, 0.2. I will not be using 0 because I'm using right rectangles. If it was the left rectangles, I would use 0, this one, this one, this one, this one, but not this one. Remember, that was this one here, the left rectangles. The height of this left rectangle, the height of this one, the height of this one, the height of this one, and this one. We do not use B if we're using left rectangles. It's important to remember if you don't draw the picture. Okay, so now let's plug it in. 1/5 is our delta x. We're going to be using B. I usually just start with the right-hand side. So that is B, 1 squared, because we have x squared here. And then 1 delta x less than that, and then another delta x less, another delta x less, all the way until you get to 1 greater than a. So we'll have 1 squared, 0.8 squared, 0.6 squared, 0.4 squared, 0.2 squared. Again, the reason why we're squaring them is because our function is x squared, and that's how you get the y coordinate. When x equals 0.2, you plug it in, that's how you get the y coordinate. When x equals 0.4, that's the y coordinate. So these are the y coordinates of each one of those rectangles. And you just take care of business and do the math. You get 0.385 approximately for that. And that was going to be an overestimate. Okay, let's do midpoint. This one, the formula is really icky. So sometimes it's just better to look at the picture. So again, here's our 5 rectangles all divided up. It's nice to just draw vertical lines through each of the delta x's. I guess that's how you say that. And now midpoints are going to be the middle of each of these rectangles. So you have to cut them in half again. So this would be like, half of a fifth, half of a fifth. What's 1/2? Like if you go in between 0 and 0.2, or 0.2 and 0.4, this is 0.1, 0.3, 5, 7, and 9. So it turned out to be not too crazy. But those are the y coordinates that we're going to use because those are the midpoint rectangles. So now when you set this up, your y coordinates will be 0.1, 0.3, 0.5, 0.7, and 0.9. And again, that's the y coordinate. We're using the equation x squared, so that's why we're squaring them in each one of these. Delta x is still the same because the width of each of these rectangles is 1/5. This comes out to be approximately 0.33. Okay, let's do one more. Given the table below, for selected values of f of x, use 6 trapezoids to estimate the value from 1 to 10 of that integral. All right, so here's something that's really tricky. You see the word trapezoid, and you jump right to the trapezoid equation, which is great if you have the function and you have the picture and you can guarantee that delta x, like let me back up for a minute, delta x is exactly the same for all of these. We have the graph, we have every known point of this equation because we have the equation. So we can make sure that delta x is the same because I can tell you exactly what y coordinate will make it so delta x is the same. Here, I don't have the equation for delta x. I'm sorry, for f of x. I don't have that. I just have a few points. And you can't make any assumptions about any points in between. Very tricky. Cannot use the trapezoid rule in this. It's because you have unequal intervals. And again, we can't guarantee. We can't do like b minus a over n. If you do that, okay, so fine. You get 9 over 6. So that tells you that the distance would be, 9/6 or 1.5 distance apart. Well, the thing is this is one distance apart. This is a unit of 1. This is a unit of 2, a unit of 1, 2, and 1 again. Like none of these are the same distance apart. Like it's all unequal. So you just have to draw this one. I guess until you see the pattern on the table, it's good to just draw a picture. Draw a picture, draw these points. We can't say anything about any of the points in between, so draw vertical lines from each of those ordered pairs and draw slanted lines to create trapezoids. And well, this one's technically a rectangle. And now you just find the area of trapezoids separately. So the first one is 1/2 times the height. Remember, the height is always the right angle. So the height in this case is the distance between the first 2 points, which is 1 and 3. And then the 2 bases are the y coordinates of the first 2 points. And remember that pattern, the pattern of the 1, 2, 2, 2, 1 thing? That's going to happen here because the next one is going to be this piece. That's going to be the height. And we're going to end up using this 8 again. So we're going to go like this. That's going to be our height, and we're going to use 8 and 6. And then the same thing happens again. The next one's going to be a height of 2. The bases are 6 and 10. So I'm like one ahead of this yellow because I'm trying to show you the pattern. So this is the distance between them, which is always the height. And then these are the 2 bases. This will be the distance between them, and then the height of the 2 bases. The distance between them, the height of the 2 bases. It's getting ugly. Hold on. Do that again. The distance between, height of the bases. Distance between, height of the bases. So this one that we're on right now, from 4 to 6, the bases are 6 and 10. The next one's going to go from 6 to 7, and the bases are 10 and 10. Technically, that's just a rectangle. The next one's going to be height of 2, bases of 10 and 12. The next one's going to be height of 1, bases are 12 and 16. So hopefully that helps you see the pattern a little bit so you don't have to draw it. I would highly recommend drawing it though, especially at first. So you just plot the points, draw the vertical lines, connect them with the slanted lines so you have separate trapezoids, and you just look at the trapezoids separately, add up the areas separately, and you get a total area. Be careful when you're given a table and not an equation. You cannot use those formulas as is, because many times they're trying to stump you because the distance between them is not equal, which means you cannot use the delta x that you find in those formulas. So be very, very careful. Okay, hopefully that helps.